right, here we are coming from West Virginia. Coming from I don't know where. But anyways, I do have joke of the day, and I know you're waiting for it. So, you know, I was addicted to the hokey pokey, but then I turned myself around. I think that's hilarious. Okay, but what I am addicted to is the slope-intercept form, the equation of a line, and I'm going to turn you around to it. So let's first take an example, a real-world example, so we can see where something like this would be useful. In this real-world example, Paula worked for X number of hours at $4 an hour. I'm not sure where her job is, but this is her pay. And then she worked Y hours at time and a half. So this is the type of company where if you work overtime, they will pay you time and a half when you work that overtime. She earned a total of $48, and I guess that's $48 maybe for that day or whatever. But anyway, she earned $48. I'm assuming it's $48 in the day. We're going to write an equation that relates X and Y, and we're going to graph the equation. So let's think about what's happening here with Paula. It says she works X number of hours, or X number of hours at $4 an hour. So when she makes that paycheck, she's going to get her base pay plus that overtime, and that'll give her her paycheck. So that's the general idea of what's happening, and I've told you many times when you have a word problem, read it in its entirety one time just to get a feeling for what's happening, and then start plugging things into that. Taking it slow, sentence by sentence. So in that first sentence, that X hours at $4 an hour, well, she's going to get $4 in the first hour. She's going to get $4 in the second hour. That's another 4. She's going to get $4 in the third hour. That's another 4. So we could repeatedly add 4, add 4, add 4, add 4 for this many hours. But what would be faster? Instead of adding. Yes, repeated addition is the same thing as multiplication. So what's going to happen here is I'm going to multiply her pay to the number of hours. And that will give us the base pay that she's got. So that base pay is going to be 4x, whatever number of hours that is. When I multiply it by 4, that will give me the amount of pay she gets there. Now this time and a half concept, this is a little bit weird. But how does time and a half, it says I'm going to take that base pay, and then I'm going to add half of that. That's what time and a half means. Base pay plus half. So if her base pay is $4 an hour, what would be half of that? Yes, half of 4 is 2, so I'm going to take the 4 and the 2, and I'm going to add them together. That's her time and a half pay. So I'm going to take that 4, I add 2, giving me 6. So her time and a half pay is $6 for every hour that she works on that overtime. How long does she work on the overtime? Well, we don't know. We're just told she works Y number of hours during that overtime. But here again, to figure out how much she's getting paid overtime, we're going to multiply the two together, just like we did with the base pay. So we'll take that $6 and multiply it to the Y, put these two together to give us the paycheck that she got. How much did she make? A total of $48. So here is our equation. Now, we can graph this because we know that we can use X and Y intercepts to graph. We've looked at X and Y intercepts. So let's talk now about graphing this. And so let's put our 2D coordinate plane up here. Now, normally we would have a 2D coordinate plane that looks like this. But this x-axis, what does it represent? Yes, it represents hours. Does it make any sense to have negative hours? No, it certainly doesn't. So we're going to take off this end of that x-axis. Now this y-axis, what does y represent? Yes, y represents, again, hours. So does it make any sense to have negative hours? Nope, still doesn't. So we're only going to work with the first quadrant of the 2D coordinate plane. So I'm going to make this a little bit bigger so that we can take a better look at this. So here is my x-axis, here is my y-axis. Now, I'm going to use my x and y intercepts, and we know that to get an x-intercept, remember, x-intercept means make that y 0. So I'm going to make the y 0, and when I do, remember that means this is completely gone. And so now I have 4x equal to 48. When I divide by 4, I get 12, giving me the point 12, 0. So that means along this x-axis, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right there is a point 12, 0. Now I'm going to get my y-intercept, And we know that to get a y-intercept, that means make the x 0. So I'm going to take this x, pull it out, put a 0 in its place. And once again, anything times 0 is 0, that term is completely gone. I'm left with a 6y equals 48. When I divide by 6, I get 8. Giving me the point 0, 8, 0 because I made the x 0. 1, 2, 3, 4, 5, 6, 7, 8. 0, 8 sits right here. And I can connect them with a straight line, hoping and praying that it's straight because I cannot draw a straight line to save my life. But this line represents all the hour combinations that she could have and make $48 in that day. She could go with 12 hours of straight time and do no overtime at all. She'll make $48. She could do no straight time and 8 hours of overtime, which isn't possible, but she could do that and get $48. Or any of these points through here, when you get their x and y coordinates, they will give you $48 worth of pay. Anything up here, she's not going to get $48 worth of pay. Anything down here, she's not going to get $48 worth of pay. Now, normally I'll put an arrow here and I'll put an arrow here. Why did I not do that? Yes, because the arrow indicates that it's going on forever in this direction, but it can't because that would get into negative hours here. This arrow would indicate it's going to go forever in this direction. It can't because that'll get into negative hours down here. It can't do that. That's not possible. Now, I want to take this and I want to do a little bit of rearranging. Let's rearrange the equation and see what happens. I want to take this equation right here, this 4x plus 6y equals 48, and I want to get the y by itself. Now, what's it going to take to get this y by itself? Yes, first I'm going to have to subtract off that 4x, and when I do, I get a 6y equals negative 4x plus 48, and then I'm going to go through and I'm going to divide by 6. Every single term is going to get divided by 6. When I do that, I get y equals, now it's a negative 4 over 6. Does negative 4 over 6 simplify? Yes, it sure does, and it simplifies to a negative 2/3. And then 48 divided by 6 is 8. So when I rearrange that equation and get the y by itself, notice that what I have here, oh, that 8 is very much like this. Yes, very much like this. This is what we call the slope-intercept form of the equation of a line. Y equals mx plus b. Notice that's what I have. Y equals, here's the m, x plus b. And whenever you've got that, like I said, this 8, very much like this, and remember, that point right there, that was the y-intercept. That is where this graph crosses this y-axis right here. So that means this b that you see right here, that is the y-intercept of that line. And remember, the y-intercept describes for us where the line crosses the y-axis. Where the line crosses the y-axis. So now let's check something out here. If I take this negative 2/3, and remember I said before that the negative can sit out front, it can sit on the numerator, it can sit on the denominator, but not both places, only one. What if I slip it up here to the numerator? And what if I start at this point 0.8 and I do rise over run, that slope that we had talked about? That would mean come down to 1, 2, and then it would mean now go to the right 3. 1, 2, 3, landing me right there. And what if I come down to again, 1, 2, and then I go to the right 3 again? 1, 2, 3. Oh my goodness, it's landing me there again. What if I come down to again, 1, 2, and I go to the right 1, 2, 3. Oh my goodness, it's doing it again. And what if I come down 1, 2, 1, 2, 3, landing me right there? So in other words, what I see right here, we know that m is always going to be slope, and slope is my rise over run. And remember, rise over run is my counting tool that allows me to get from one point on the graph to another point on the graph. And like we've talked before, if I would have slipped that negative down here, what would have happened is I would have gone from here, I would have gone up to left 3, oh, still same point, up to left 3, up to left 3, up to left 3. It would have still worked. So my point is this. When you have the slope-intercept form of the equation of a line, and notice this is the slope-intercept form of the equation of a line. This is not your formula for slope. Because a lot of times when I say, what's the formula for slope, everybody goes, y equals mx plus b. No, y equals mx plus b is the slope-intercept form of the equation of a line. When I have that, I can pull the slope out because the slope is going to sit right in front of the x, and that will give me my counting tool. I can identify my y-intercept, which is this b right here, remembering that in coordinate form it'll be 0 and whatever that number is, because it crosses this y-axis. On the y-axis, any point over here has no left or right movement at all. No left or right movement indicates the x-coordinate is going to be 0. But that y-intercept will tell me where it crosses the y-axis. And so what I can do is I can graph the line using only those two pieces of information. It's beautiful. So the catch is, though, this is a great counting tool. It's wonderful. Rise over run is the best thing ever. But I have to have a place to count from. What a lot of people do, they make the mistake of starting at the origin and counting up to left 3, up to left 3, up to left 3, making the line like this and putting the y-intercept on there. Actually, they'll go up to left 3, they'll put the point right there, and then they'll put their y-intercept on there and connect them like this. But you can see clearly that that line that would go through there is definitely not the right line. This is the right line. So I need to stress to you, it's a wonderful counting tool, but you have to have a place to count from. So you always put your y-intercept on there first. Always put the y-intercept on first. Then use that counting tool of rise over run after you put your y-intercept on there. And that's exactly, if we didn't have this and we had it written in this way, that's what we would do. We would put our y-intercept of 8, meaning 0, 8, right here. And then we would use this slope of negative 2/3, and we would come down to right 3, down to right 2, down to right, all the way through and connect them. Or we'd go up to left 3, up to left 3, and notice that would still be part of this line. And that would get us every point on the line. So let's practice this a little bit. Oh, and I do want to stress to you before we get into the practice, notice the key thing right here, the y is by itself. You know that you're in slope-intercept form, and you can pull that m out in front of the x, you can pull that y-intercept out when the y is by itself. It has to be by itself. If it's not, you are not in slope-intercept form, and you can't do any of this. You have to have the y by itself. That's why I said, let's take this, let's rearrange it, and let's get that y by itself and see what happens. So, let's continue on with some examples. You know I like to give you lots of examples, so you're very comfortable with this. In each of these examples, we're going to find the slope, we're going to find the y-intercept, we're going to graph them using both, just like we just did. Now remember, in order to pull out the slope, pull out the y-intercept, that means it has to be in slope-intercept form. Slope-intercept form is y equals mx plus b. And remember, that means the y is by itself. Notice in the first example here, the y is by itself. So since it is, I can easily pull out the slope. It always sits right in front of the x, so my slope is going to be 1/3. And I can easily pull out that y-intercept. Now, my y-intercept is 2. Some teachers, some books will allow you just to list it as a 2. I'm not a fan of that, because it's very important that you know where the 0 goes in that coordinate form. Lots of people get that 0 twisted. So I'm going to always put it in coordinate form. Now remember, this is a y-intercept crossing this axis here. On this axis, none of these points have left or right movement. That means every one of them, the x-coordinate is going to be 0. The y-coordinate in this case is going to be 2. So in order to graph it, remember, wonderful counting tool. Rise 1, run 3, rise 1, run 3. However, I got to have a place to start from. I have to I get so excited. I have to have a place to count from. So I'm going to start with my y-intercept of 0, 2 right here. Now I'm going to use that slope. And since this is positive, that means go up 1. Since this is positive, that means go to the right 3. That will land me right here. And how many points does it take to make a line? 2. That's all you need. So I'm ready to connect these and pray that it's straight, because I cannot draw a straight line to save my life. And this is the line for that equation, y equals 1/3 x plus 2. Remember, the equation is the name for the line. Just like my name is Lori James, and Lori James represents this line, if you want to call it, well, this name represents that line. All right, let's try a few more. So once again, I got to pull out the slope, pull out the y-intercept. Is this in slope-intercept form? Yes, it is. The y is by itself. So when it's in that form, easily can identify that slope sitting right in front of the x. My slope is a -5/2. My my y-intercept is going to be this number right back here. And like I said, I like to put it in coordinate form because notice up here, 0, 2, if I would have twisted it up and put 2, 0, well, 2, 0 is going to sit here. That's going to shift that line. That's going to sit the line down here. That's not the right spot. So it's critically important that you know where that 0 goes. That if it's a y-intercept, the 0 goes in the x-coordinate. So now I'm ready to graph it. Fantastic counting tool, but I have to have a place to count from. So I'm going to start with my y-intercept of 0, 14. That's right up here. Now that negative, remember, it can sit on the top, it can sit on the bottom, it can sit out front, but not top and bottom, because if it's top and bottom, that indicates positive. This is clearly a negative. Most people like for it to sit up on the numerator. I'm going to go with that, but either way is perfectly fine. That means my rise is negative. So do I go up or down? Yes, I come down 5. 1, 2, 3, 4, 5. My run is positive, so do I go left or right? Yes, I'm going to go to the right 2. So down 5, right 2 lands me here. How many points does it take to make a line? Just 2, and I've got the 2 that I need. So I can connect them, and like I said, with me, you got to pray that it's straight line, because I am not good at that. Now, let's go back and review. Remember that remembering slope that we had talked about in the previous video? We said puff, puff, positive. Remember puff, puff, positive? Did this have a positive slope? Yes, it did. Remember nice, negative? Okay, did this have negative slope? Yes, it did. So this is all coming together, and you can see how valuable all these little tips and tools are that help us to get to these right answers, or at least we can double check ourselves and make sure that they're right. Now, take a look at this one. I need to pull out the slope, I need to pull out the y-intercept, but I can only do that when the y is by itself. The y is not by itself here. So what am I going to do to get the y by itself? Absolutely, I'm going to subtract that x, and I'm going to subtract it from both sides, and that will give me y equals -x plus 5. Remember, sign in front's the sign that goes, that name tag. When you go to a meeting, you never put your name tag on the back because I can't figure out who you are. Put your name tag on the front so I can identify your face with your name. Name tag, sign in front, sign it goes. That's a positive 5 right there. Now I can identify my slope and my y-intercept. My slope is the number sitting right in front of the x, -1. My y-intercept is going to be this number right here. Again, I'm going to put it in coordinate form because I like to know where that 0 goes. Because it's crossing this y-axis, that means the x-coordinate is 0. So now I'm going to graph it. Wonderful counting tool, but I have to have a place to count from. So I'm going to start with my y-intercept of 0, 5, which is right here. And now I'm going to count. Remember, it's rise over run, which means I need a fraction. So therefore, I'm going to turn it into a fraction by simply putting it over 1. Anytime you have an integer to turn it into a fraction, just put it over 1. Very easy. So now I'm going to rise -1. Rise is vertical, so do I go up 1 or down 1? Yes, that means come down 1. Run is positive, so do I go to the left negative, or to the left one or to the right one? Yes, I'm going to come to the right one. So I go down 1, right 1. There it is. And connect the 2 and pray that it's straight because I cannot draw a straight line. Oh, I forgot to identify these. This is for x plus y equals 5. And the green one, I apologize for not labeling that. The green one is for y equals -5/2 x plus 14. Okay, let's try a couple more. So again, in order to pull out that slope and that y-intercept, I've got to have that y by itself, and it's not right now. So I need to do some adjustments. So to get the y by itself, first I'm going to subtract that 4x from both sides, and when I do, that will give me 3y equals -4x plus 9. And at this point, I'm going to go through and I'm going to divide by 3, and I'm going to divide every single term by 3. When I do, that will give me y equals -4/3 x plus 3. The y is now by itself, so I can pull out that slope, I can pull out that y-intercept. So my slope in this case, I'm going to put it right over here just to make sure I preserve enough room. My slope is sitting right in front of the x, it's a -4/3. And my y-intercept, remember, yes, it's that number that's sitting by itself, but I'm going to put it in coordinate form Because it's crossing this y-axis, that means that the x-coordinate's going to be 0, y-coordinate's 3. And I am now ready to graph that. So I have a wonderful counting tool, but I've got to have a place to count from. So I'm going to start with my 0, 3, my y-intercept, and now my slope of negative 4/3. Like I said before, the negative can sit on the numerator or the denominator, not both, because that will make it positive, one or the other. And let's just go ahead and let it sit up there on the top like we've got it. So from here, the fact that my rise is negative, yes, I'm going to come down 1, 2, 3, 4. My run is positive, yes, I'm going to go to the right 3, landing me right here. And I'm going to connect the 2. There we go. So this represents the line 4x plus 3y equals 9. One more. Okay. So once again, got to get the y by itself in order to figure out what the slope and the y-intercept are. So I'm going to subtract that 3x from both sides, giving me negative 2y equals negative 3x. And now what I'm going to do is go through and divide by that negative 2 to get the y by itself, and that will give me y equals, notice negative divided by negative is positive, 3/2 x. So I'm able now to pull out that slope and that y-intercept. My slope sits right in front of the x. Now that the y is by itself, it sits in front of the x, 3/2. And my y-intercept, now wait a minute, I need y equals mx plus b, but it doesn't look like anything's been added. So when it doesn't look like anything's been added, what has been added? Yes, a 0. So my y-intercept then is going to be 0, 0. So this is going to start here at 0, 0. My slope of 3/2 means rise 3 up because it's positive. 1, 2, 3. Run to the right 2 because it's positive. There we go. And that gives me the line for 3x minus 2y equals 0. And let's double check with that skier. Remember, puff, puff, positive here. Did that have positive slope? Yes, it did. Nice negative here. Did it have negative slope? Yes, it did. So it all comes together. Okay, so what we did in these examples is we took the equation, we pulled out the information, the slope and the y-intercept, and used those to graph. Now we're going to work backwards, and we're going to write the equation being given the slope and the y-intercept. Okay, in each of these examples, we are told that we're going to write the equation of the line given the slope and the y-intercept. So in order to write the equation, remember, we need y equals mx plus b. That is the slope-intercept form of the equation of the line. Now here, I'm given a slope of negative 2/3, so that's going to go right here for the m. So I'll have y equals negative 2/3 x plus the b is 4. So I'll put the 4 right in there. Ta-da! There it is. Slope-intercept form, the equation of a line. So now let's try this one. Y equals mx plus b. My m is 1. 1x. And you know that whenever you have a coefficient of 1, you don't need to show that. So I'll just have y equals x. Now plus a negative 4 would be the same thing as y equals x minus 4. Ta-da! There it is in slope-intercept form. This last one tends to trick people, because what happens here is my m is 0, and when I put a 0 right there, and I have 0 times x, plus my b is now 10, what throws people off is the fact that 0 times anything at all is just 0. So really what I have is y equals 0 plus 10. And really 0 plus 10 is just 10. So my equation for that one is y equals 10, which feels weird because I'm missing my x. But let's think about what happens in this one. Remember the idea of graphing those horizontal and vertical lines, and I said read this as y has to be 10? So if I was to graph this, y has to be 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here's y has to be 10. And remember we said we don't care what the x is because there's no x in here at all. So that means that make sure that every one of the y coordinates is 10, x can be anything. And remember that generates this type of line. Now that is a horizontal line. Picture that skier. What type of slope is a horizontal line? Remember the skier was sleeping and the z's meant 0 slope. What type of slope were we told we had? We were told we had 0 slope. So this does make sense to be the equation of that particular line. So I hope this helps with the idea of the slope-intercept form of the equation of a line. Remember, y equals mx plus b. When the y is by itself, the number in front of the x is the slope. The number right here is your y-intercept. And remember, the y-intercept being that it crosses the y-axis, you do need to put it in this coordinate form right here. And the x-coordinate will always be 0 because on this x-axis, or sorry, on the y-axis here, you have no left or right movement, so the x-coordinate will be 0. And remember, in terms of graphing it, this is a wonderful counting tool, but you have to have a place to count from. So put that y-intercept on there first, then use that rise over run to count from there and get all the rest of the points on the line. I hope that helps. Have a great day.